So I'm going to show you guys something just kind of in general here. So let's do transformations of parent functions. Now, when you're going through that assignment, make sure that you're reading it so that you know that you're answering all of the questions, because some of those have 2 questions in them and are thus worth 2 points. So like there might be one that asks, how does this change happen, and then what would happen if you did this, or like the graphing ones, they tell you to graph it, but they also tell you how does it change from the parent function. So like that very first one, you don't have, like, graphing it isn't the end of the answer. The answer is graphing it and then saying that it shifts it up 5 from the parent function. Does that make sense? And then similarly on like question 3, you graph it and then you say that it moves from the parent function left 2. So like there's 2 parts to there, so just make sure that you're reading the questions thoroughly. All right, so transformations of parent functions. All right, so this is kind of sort of in general. This isn't all-encompassing, but this is kind of a theme that's going to pop up again and again as we go through the class. So if you have a parent function, f of x, and you want to make changes to it, if we take this new function called g of x, and when we talk about functions, almost always in math they use f and g. It's just a thing. So if we have a function g of x, we're going to do a times x minus h plus k. And this might look a little confusing at first, but it is a generalization that most of you guys have been able to see by looking at the assignment that I just had you go through. First of all, the easiest thing to do to any function is to move it up or down. And the reason I think that's easiest is because it happens exactly how you think it should. So like this number here, this k, this tells you how much you're moving it up or down. And it is exactly as it appears. So like if it's a plus 3 at the end, you're moving the parent function up 3. If it's a minus 2, you're moving it down 2. Okay? It is exactly as it appears. Now the next one that was on the thing that is a little more confusing is this h. And this tells you how much you're moving it left or right. Move left or right. And it's a little more confusing just because it's the opposite of what you think it should. If you want the function to move right, it needs to be minus however many units you want it to move right. If you want it to move left, it's plus. One thing that you can think about it, well, I'll get to that in just a second. One way to kind of make it a little easier for you. This number a in front is how much it's going to be stretched or compressed. So if the number that's in front is bigger than 1, so if it's 1.5 or 2 or 3 or a billion, that's a stretch. If it is between 0 and 1, so like 1/2, 1/3, 1/4, that's a compression. It makes the graph wider if it's between 0 and 1, and it makes the graph skinnier if it's greater than 1. Kind of, sort of? Okay. And then the other thing, well, we'll save that last part. Okay, so if I give you guys a function here, we'll call this function h of x. And we'll say that h of x is 1/3 times the square root of x minus 4 plus 7. First of all, I'll let you guys write that down. The first question that you need to know is, which parent function is that based on? Square root, right? Because it has a square root in it, so it's going to be based on the parent function of the square root. So what we're going to do for like this function, essentially what it is it's the square root function. Is it moved up or down at all?
Yes, it's up 7.
Up 7, right? Everybody see that? The plus 7 at the end means the whole function just like up 7 as it was. Okay? Is it moved left or right at all?
Left 4. Right 4.
Yeah, see, there's the thing, is that it's moved left or right. Absolutely, and it's moved 4 units, but because it's a minus 4, you're moving it right 4. Now here's the best way that I've thought of to try to explain that, is what number would I have to put in the parentheses? What number would I have to put in for x to make this whole thing be 0? Plus 4. Like if I put in positive 4, this parentheses, forget about everything else. If I put in positive 4, that parentheses would be 0, right? Okay. So like instead of thinking about this as being the -4, it's what has to counteract that in order to make it be 0. And what counteracts it is moving it right forward, +4. Does that make, if that doesn't make sense, then just think it's the opposite of what it should be. Think if it's -4, you're moving it right, even though you think you should move it left, okay? Now, the last thing is this 1/3 that's in front. And this is the last set of questions on that assignment I gave you guys. Because there's that 1/3 in front, what's happening is it's compressing all of the values to be 1/3 of what they were, meaning it's making the function wider. So it's compressing the values to be 1/3 of what they were. What was 1 is now 1/3. What was 2 is now 2/3, so on and so forth. So it's a compression by a factor of 3. Does that make sense? Okay. Now, if I wanted to use this to start to build functions, if I wanted to go in the other direction, like I know that I have some parent function here, I'll call it f of x. This doesn't have to go in your notes. I just want to make sure everybody's kind of on the same page. I'm going to say I've got f of x is x squared. If I wanted to, and don't shout this out, I'm going to call on people for this. If I wanted to move that function up 3, what would my new function have to be, Aaron?
X squared plus 3.
Great. If I wanted to move it down 10, what would my new function be, Brody?
F of x minus 10.
X squared minus 10. Sweet. If I wanted to move it up 1.5, what would the new function be, Cicely? Awesome. All right. If I wanted to, now let's think about left or right here. Okay? So Maria, you're on deck. If I wanted to move it right 2, what would I have to have my new function be? Not x squared minus 2? Okay.
Wait.
If I wanted to move it right 2, here's where it goes. Like, it needs to go in the parentheses with the x and then squared.
Yeah.
So what would it have to be to move it right 2?
It have to be in.
Right, in there.
Yeah.
And how would you say it?
X minus 2 squared.
There we go. I would prefer if you said quantity, but I got what you meant.
Okay.
So we're on the same.
Okay.
Thank you for being the first one to try that. Okay, Dylan.
Yeah.
If I wanted to move it left 3, what would it be?
Left 3 then. X plus 3 times 3.
Awesome.
This could be a problem having 2 Dylans at the same time.
Yeah.
I
wasn't really sure.
Okay, I will. Should I say your full names from now on? Will that feel like I'm yelling at you?
Call me Robert.
Okay. Bob
Well,
Dylan.
Bob.
I guess I never realized that. Bob Dylan. Was that intentional?
No, it wasn't.
Wow.
Yeah, I
I would
noticed
have
that
a
when
long talk with your parents.
Oh, I
when
know.
I first learned that his first name was actually Robert, I was like, so you're Bob Dylan?
Yeah.
Oh,
Okay,
yeah, I guess
wow.
I am.
Yeah, seriously, okay. So many jokes, just holding them back. Okay. So, James, if I wanted to take the parent function x squared and I wanted to move it left 1, but then also down 4.
F of x equals, in parentheses, x squared plus 1.
X plus 1 and then the squared. Oh, didn't mean to slow you down, but go ahead. And then, so that's moving it left 1, x plus 1 quantity squared.
And how many?
Down 4,
Oh, minus 4.
minus 4. Awesome. Are you guys kind of seeing how this works?
Yeah.
All right. So now that you've got a kind of sort of grasp on this, make sure that you go back through and take a look at all the questions that you may or may not have answered, or make sure that you answered every part of the questions that were on the assignment. As this is Monday, this assignment is not due for realsies until next Tuesday.
For real.
Okay. When you're done with it, you can hand it in though, and I'll grade it, and it'll be back in the folder. But the assignment is due next Tuesday. Kind of, sort of. Don't take advantage of that too much. Like, don't leave all of this week's assignments to do Monday night. That's bad news. You're gonna have a bad time.
Probably what's going to happen. I'm not gonna lie.
Don't do that. Don't do that. You're gonna have a bad time.
I'm going to back
But so that's the notes for today. Go ahead and finish the assignment, and then tomorrow we'll take what is kind of sort of clear and we'll make it super confusing. So yes. Oh, this is like the f of x, like the original. Like
Yeah,
you replace
I got
the
it.
x as the original function with x minus whatever you're going to think.
Okay.
Alright. The reason I did this is so that like you can use, like this is the parent function. Like this f of x
hit the wrong button.
plus A goes on the outside, and then this goes kind of inside. Okay.
Thank you.
Yeah. All right. Make sure that you're asking any questions. If you don't know what you're doing, you can ask people around you if you don't want to ask me. Yep. Yeah. You put the negative. And we're going to talk about that now. But that's what the negative does. Sure. Opening.
Yeah, I'm the only birdie in school again.
Oh, okay, great.
And it was confusing having math class with Brody Smith some days.
I can understand it would be, especially since the two of you are not quite chefs. If one of you were quite